Hello everyone, today we were going to talk about mechatronics. But first, let us define mechatronics. Mechatronics is a multidisciplinary field of engineering that blends mechanical, electrical, and computer engineering to design and create intelligent products and processes. It's the backbone of modern automation and robotics, enabling machines to think, sense, and act with precision. And now, let's move to the role of software in mechatronics and how it interacts with hardware components. Software in mechatronics serves as the control center that makes mechanical and electronic components work together intelligently. And it interacts physically through devices such as sensors and actuators, logically by interacting with users of software to analyze data and make decisions. And let's move on to types of sensors used in mechatronics. First, temperature sensor. It measures heat levels. Example, HVAC systems and engine control. And we have proximity sensor. It detects objects' presence or distance. Example, robotics and touchless switches. Pressure sensor. It measures force per unit area. Example, hydraulic system and weather tools. And we have flow sensor. It measures fluid or air flow. Example, automotive fuel systems. Motion or position sensor. It tracks movement or orientation. Example, drones and robotic arms. Last but not the least, we have light or optical sensor. It detects light intensity or color. Example, cameras and ambient light sensors. And we have types of actuators used in mechatronics. First, we have electric motors. It rotationally or linear motion. Example, conveyor belts and robotic joints. Second, hydraulic actuator. It uses fluid pressure for force. Example, heavy machinery and car brakes. And we have pneumatic actuator. It uses compressed air for movement. Example, pick and place machines. And we have thermal actuator. It uses heat to expand or contract materials. Example, thermostats and thermal printers. And piezoelectric actuator. It precise movement via voltage. Example, micro-positioning tools. And now let's move on how sensors collect data and actuators take actions based on sensor data. And now you must be curious how sensors collect data. Sensors detect changes in the environment, such as temperature, motion, pressure, or light, and convert these physical signals into electrical signals. These signals are then sent to a microcontroller or processor for interpretation. And how actuators take actions based on sensor data. Once the software processes sensor data, it sends commands to actuators to perform specific actions. Actuators convert electrical signals into physical motion or force. And now let's have analog and digital signals. Analog signals are continuous and vary smoothly over time. Think of sound waves, light intensity, or temperature. While digital signals are discrete, using binary values. They're used in computers and digital electronics. And now let's move to the purpose of signal processing in mechatronics. In mechatronics, signal processing turns raw sensor data into useful information so controllers can respond effectively. And let's have the ability to convert between digital and analog signals. Analog to digital conversion or ADC, this process turns a smooth analog signal into a digital one. And here are the steps: sampling, quantization, and encoding. Digital to analog conversion or DAC. This turns digital data back into a smooth analog signal. The steps are decoding and filtering. And here's a set of simple control algorithms commonly used to perform basic tasks in mechatronic systems. Last but not the least, how mechatronics technology is used to address specific real-world problems and improve efficiency. Mechatronics technology solves real-world problems by integrating mechanical systems with electronics and intelligent control, leading to smarter, faster, and more efficient solutions across industries like healthcare, manufacturing, and transportation.